I'm going to briefly introduce some of the research that we're doing here at AIT on securing future power systems, the smart grid. So I think the previous speaker very nicely introduced the topic of smart grids and some of the potential there. So what is the smart grid? So basically, the future energy systems that typically include an increased amount of renewable energy sources. So I think we were hearing about wind there. Solar power is also important, and things like this photovoltaic inverter here. So there's a lot of renewable energy sources in the future grid. There's also new load in terms of electric vehicles and potential for shifting that load to help with the issue that some of the new renewable energy sources might not be available all the time. So to do all of this, to deal with the new energy sources and these new loads and the ability to shift them, we need new ICT systems and industrial control systems that implement, if you like, a distributed monitoring solution across the power systems, and based upon that monitoring information, so the type of information we heard about before, implement some control, so adjust the behavior of the power network. So set against this, of course, so basically this introduces sort of new cybersecurity threats, the potential for new threats, and also new vulnerabilities into the infrastructure, because we are using more ICT, and the implications of those attacks are more significant because we are dealing with physical systems. So an attack could result in some problem in, for example, power outages and so on. So there's some evidence to suggest that this is starting to happen in power systems. So the ICS CERT in the US publishes documents about the distribution of attacks to different sectors, and consistently the energy network is the highest ranking in terms of attacks that are received. And traditionally, to some extent, those attacks have largely focused on cyber issues, so basically data exfiltration, so trying to understand how these networks are operated, maybe more classical information security problems. And increasingly, what we're seeing is some of these cyber attacks are focusing on resulting in some kind of physical implication to the grid. So, and this is not just in energy networks, so this is in other types of industrial control systems. So the canonical example that we saw recently, or 2 years ago, was there was a cyber attack to a German steel mill that resulted in some problems there, some physical manifestation that damaged a plant, which cost in the order of €1 million. So this is something that we've been tracking at the AIT for a while, and last Christmas we got a little gift, I suppose, for our research, where there was a fairly significant cyber attack in the Ukraine last year. So this was a sort of advanced persistent threat, so a multi-stage attack that resulted in a power blackout, basically. So this cyber physical attack is beginning to be seen in real life and could be something that gets more important in the future and more common. So we've got this energy network, and it's more vulnerable to attacks, cyber physical attacks. So what are we going to do about it? What do we do at AIT? So basically what we try and do is take a risk-based approach to building more secure energy systems. So along the top of the image here, we have essentially the 4 fundamental stages of doing a risk assessment. So context establishment, determining what the system is that you're trying to analyze. So in this case, it might be a particular smart grid or energy network. Analyzing the impact of a cyber attack, so that might be from an information security point of view, so data loss or so on, or maybe could be some of these physical implications, whether it's power outages. Likelihood assessment, so how likely is an attack to occur? And that's usually some combination of an understanding about the threat actors and their capability and the threat landscape and the vulnerabilities that are associated with your system. And then once you understand those two things, you can get an idea about the risk, and then you implement some kind of risk treatment to manage those risks. And for each of these columns, AIT, we're producing technologies and solutions and know-how that address those issues. So we have a number of projects that are looking at secure architecture definition or the specification of security architectures and ICT architectures for the smart grid. So understanding how the SCADA systems work, what are the contemporary protocols, how they should be arranged such that they're secure, for example, into security enclaves, using firewalls, and so on. In terms of impact assessment, so we have a lot of work that's looking at the analysis of cascading effects. So if you have one system that's damaged, what's the probability of that propagating to other systems? Also looking at the cyber-physical attack implications. So if I have a cyber attack, what is the potential implication on my power system from an operational point of view? And for that, we work with our colleagues in the energy department to develop co-simulation tools. Then we develop specific approaches that look to try and identify chains of vulnerabilities that could result in some attack occurring in a system. So this connected vulnerability assessment tool. And then specific threat catalogs that can be applied to technologies that relate to the smart grid. So again, we can use those for likelihood assessment. And then one of our assumptions basically is that all of this will fail. So the stuff that Ross was talking about will fail and everything else, and the attackers will be successful. And so what we're looking at is technologies and frameworks that allow us to adapt the behavior of the grid such that it continues to operate in a useful way or a safe way if there's a successful cyber attack. And the idea is we want to integrate all of these technologies into an overarching risk management process. So we're doing that in the context of ISO 27005. Okay, so just to mention a couple of reference projects where we're working. The first is the Sparks project, was mentioned earlier. So I'm the coordinator of that project, and there we are looking at medium to low voltage distribution networks that have renewable energy resources and a future grid architecture called microgrids. So trying to analyze the risks to those, coming up with key technologies that we can use to detect and mitigate the attacks to those. So for example, with our partners at RSA, looking at security analytics techniques using big data to detect anomalies. Those techniques and if you like, the risk management solutions that we're developing, we then apply in a national project that we've called RASSA Architecture, where we're trying to develop, along with Austrian stakeholders, so DSO solutions providers and so on, a security architecture or reference architecture for Austria for two important subsystems in the smart grids, specifically around secondary substation automation, so doing voltage control on the medium and low voltage line, and in the customer premises with respect to things like demand response management, where we apply these, for example, the threat catalogs to understand the risks and develop suitable architectures. So that's my brief introduction to what we're doing here at AIT in terms of smart grid security research. I'm very easy to find. I'm just here, along with my colleagues. So if you have any questions, I'm happy to try and address them for you. Thanks.
Thank you, Mr. Smith.